Lesson 8.2, Properties of Logarithms, Part 4, Evaluating. Now, we've already applied all of the log properties, the expanding, condensing, the change of base formula, and we've actually already evaluated logarithms as well, but we're going to take a second pass at evaluating logarithms now that we know the log properties, because there are certain logarithms when you evaluate, they're pretty straightforward. Others are not so straightforward, and those ones that are not so straightforward can actually be a little bit easier if you apply the log property first. So once again, to recall, we have four properties of logarithms: the product rule, quotient rule, and power rule, and then of course the change of base formula. Remember that the change of base is whatever base you're given, you can convert to whatever base you want to. Put the old base on the bottom, the old input on the top, but of course ln and common log are the more useful to use as your new base. So here are four questions. Let's take a moment, pause here, take a look at each of these questions in turn, see what you can figure out on your own. Play when you're ready. Okay, so if you try to evaluate, look into the first one, log 5 plus log 2. Again, we're not allowed to use a calculator here. I could just type this into my calculator and get an answer because they're common log questions, but I'm not allowed to use a calculator. Now, if I try to evaluate log of 5, there's really nothing I can do there. Base 10 and base 5 do not have a common base between them. Now, I could attempt to use the change of base formula, but that's only useful if I'm trying to get it into a calculator. Not allowed to use a calculator here. The key to this one is recognizing that I have two logarithms being added together. And when I'm adding, I can turn addition into multiplication. So instead of treating this as log 5 plus log 2, treat it as log of 5 times 2. 5 times 2, of course, is 10, and now I can evaluate the logarithm and get 1. So in order to evaluate the logarithms, I'm actually going to condense that into a single logarithm before I evaluate. Now with that in mind, if you want to pause for the second one, feel free, play when you're ready. All right, taking a look at the second one, subtraction is going to become division. 24 over 3 is 8, log base 2 of 8 is 3. I would not have been able to evaluate these logarithms separately, but once I condense it, now I can evaluate. Taking a look at the third one, now be careful on this one because this one has that 1/3 up front. I don't want to go straight to converting subtraction to division. I want to get rid of that 1/3 before I do that. Bring that 1/3 to the top. That's going to be 8 to the 1/3 power. And then 8 to the 1/3, that really means cube root of 8, which is 2. And then from here, I can condense subtraction to division. 18 divided by 2 is 9. Log base 3 of 9 is 2. Final answer. And the last one, we're going to bring the 2 to the top as 3 squared, which will be 9. Then we will condense addition to multiplication. 9 times 4 is 36. Log base 6 of 36 is 2. All right, now let's look at these two. Now with these, there's a couple of different approaches. One, I think, is the most obvious route, which hopefully you're looking at this and asking me why I'm bothering with these questions because we've already practiced something like this. That would be the obvious route, and then there's a less obvious route that uses a different property. But I like to ask these questions here because there's the most common mistake that students make, and that's just to straight up divide. 16 by 2 is 8, so the answer is log 8. No. No. Log of x divided by log of y is not log of x over y. Keep in mind, log of x over y, that's actually log of x minus log y. And log of x minus log y is not the same as log of x divided by log of y. If you try to say log of 16 over log of 2 is log of 8, then you're straight up saying that division and subtraction are the same thing. That's not what the log properties say. We can convert division to subtraction, but it is at no point have I suggested that division and subtraction are interchangeable. Log of x over log of y, you cannot just divide the x by the y. Now, the obvious thing that hopefully you already recognize is that log of x over log of y, that's the change of base formula. That's just log base y of x. And that, I think, is the straight up easiest way to approach this problem, is simply recognize, oh, log of 16 over log of 2, that's just the output of the change of base formula. So working backwards, I can say, well, that's just log base 2 of 16, which is 4. 2 to the 4th power is 16. The answer is not 8. The answer is not log of 8. The answer is 4. I could do the same thing on the second one. That's just log base 9 of 27. Rewriting as 9 to what power gives me 27. Going through the process, you're going to end up with 3 halves. So these should be pretty straightforward questions, thinking of it in terms of the change of base formula. But I do like to point out the other way to approach these problems is using the power rule. Recognizing that log of x to the y is the same thing as log of x times y. Well, 16 and 2, I can't divide them directly, but I can rewrite 16 as 2 to the 4th. If you recognize that the numerator and denominator have a common base, 16 and 2 have a common base of 2, rewrite 16 as 2 to the 4th. 2 doesn't need to be rewritten, but it would technically be 2 to the 1st. And then using my power rule, I can bring that 4 to the front as 4 times log of 2 over log of 2. And then here, hey, look at that. We can just cancel out log 2 and we're left with 4. Same answer we got using the change of base formula, just a different approach. Using that same technique over here, log of 3 cubed over log of 3 squared, bringing the exponents to the front and canceling out the logarithm, we get again the exact same answer we got using the change of base, 3 halves. Personal preference, how do you like to think about these problems? I don't really have a preference. Sometimes my brain will jump directly to change of base. Other times my brain will jump directly to rewriting it with a common base and using the power rule. It's just personal preference. Here are 2 more problems. Pause here, play when you're ready. Now we looked at some problems similar to these in lesson 8.1, part 2 and 3 would have been, and we already established some techniques for evaluating this. Just to recap those old techniques, for instance on ln of 1 over e, I could rewrite 1 over e as e to the negative 1, and then recognizing that special property that we established way back when, that log base b of b, as long as the base matches the base, ln is base e, the expression is e to the negative 1, we can actually just cross out ln and e, and we're left with negative 1 as my answer. I think is a pretty straightforward way of evaluating this particular logarithm. Works great, use it, don't use it, that's fine. There is an alternative. Anytime I'm taking the log of a fraction, I always think of this other rule, the quotient rule. Log of x over y is log of x minus log of y. So whereas I could start by rewriting 1 over e as the exponential e to the negative 1, I could also start by just simply breaking that up into 2 separate logarithms, log of 1 minus log of e, or ln of 1 minus ln of e. ln of 1 is of course 0, ln of e is of course 1, and 0 minus 1 is still negative 1. Now again, it is your choice how you want to approach this problem. Whichever technique you think is more obvious, go with that technique. As I've said before, properties of exponents, properties of logarithms, there are often multiple routes to a correct answer. Through practice, we develop our own intuition and our own personal opinions on what routes or what techniques we prefer to use. Practice enough of these, and then you'll decide how you want to do it. So go ahead and take a look at the second problem. Pause here, play when you're ready. So with this one, you could use either technique, although on this one, I actually think the newer technique of pulling it apart using the quotient rule would actually make this problem a little bit easier. So log base 3 of the top minus log base 3 of the bottom. Notice that I've rewritten square root of 27 as 27 to the 1/2. That's going to allow me to bring that 1/2 to the front using the power rule. And then log base 3 of 9, that's going to be 2. Log base 3 of 27, that's going to be 3. And let's just clean this up. 3 times 1/2 is 3 halves. And 2 minus 3 halves, keep in mind 2 is really 4 halves. 4 halves minus 3 halves is 1/2. Final answer. Just to point out that we could have done this by rewriting 9 over square root of 27 as an exponential, which would be the old way of doing this. 9 over root 27 is really 3 squared over the square root of 3 cubed. Square root of 3 cubed is really 3 to the 3 halves. 3 squared over 3 to the 3 halves, we would subtract the exponents and do 3 raised to the 2 minus 3 halves, which is still 3 to the 1/2. And then I'd be able to start the problem log base 3 of 3 halves by canceling out log base 3 and 3 and get 1 half. Honestly, I don't really see a difference in the complexity of the two techniques. It's a matter of, do you prefer to use set of rules option A or set of rules option B? Practice, 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 build that intuition. Once you've mastered the rules, then you can play with which rules you want to use on a particular case. All right, here are two more. Pause here, play when you're ready. All right, looking at the first one, uh-oh, trig. Are you allowed to forget trig? Of course you're not allowed to forget trig. So, starting with sine of pi over 4 using the unit circle, sine of pi over 4 is still going to be root 2 over 2. All right, from here, we can either rewrite root 2 over 2 as 2 to a power, or we can just jump to the quotient rule. That's the rule I like to use. So I'm going to start by breaking it apart. Log base 2 of 2 to the 1/2 minus log base 2 of 2. 1/2 comes to the front, and log base 2 of 2 cancels out. We're left with 1/2 minus 1. 1/2 minus 1, that's just going to be negative 1/2. Final answer. On the second one, we'll start by condensing log of 20 minus log of 2 into log of 20 over 2, which of course is just log of 10. Log of 10 is going to be 1. And now cosine of 1 is not 0. Cosine of 1 is not pi. It's not 2 pi. It's not pi over 2. It's not 3 pi over 2. It's not pi over 4. It's not any of those. Cosine of 1 is cosine of 1. Often we look at cosine of 1 and we just make this association that 1 is 0, 0 is 1. No. 1 is the angle. If you look at your unit circle, there are no angles labeled as 1. 1 is a ratio that appears on your unit circle. So cosine of 0 is 1. Cosine of 1 is not 0. Cosine of 1 is I have no idea. It's some ugly decimal that does not appear on the unit circle. Cosine of 1, final answer.